CFA Level 1 Practice Questions. Learning Module, Estimation and Inference. Topic, Sampling Methods. In non-probability sampling, the primary limitation is that the sample is always larger than in probability sampling, increasing costs. B. There is no objective way to measure how well the sample represents the population. C. Each subgroup of the population is automatically proportionally represented. An analyst is studying the performance of mutual funds across three categories. Equity funds, 70% of the population, bond funds, 20%, and money market funds, 10%. To ensure the sample reflects the population, the analyst should most appropriately select 100 equity funds, 100 bond funds, and 100 money market funds. B. Select funds randomly across all categories without considering their proportions. C. Select 70% equity funds, 20% bond funds, and 10% money market funds, using simple random sampling within each category. An analyst wants to examine credit risk across regional banks. She groups banks by geographic region, Northeast, Midwest, South, West, and then randomly selects banks from each region in proportion to the region's share of the total banking population. Which sampling approach is she most likely using? A. Cluster sampling. B. Stratified random sampling. C. Simple random sampling. An analyst wants to estimate the average P/E ratio of all firms in an index. She randomly samples 40 firms and finds a sample mean P/E of 18, while the true population mean is 20. Which of the following best describes the sampling error in this case? The difference of 2 between the sample mean, 18, and the population mean, 20. B. The sample standard deviation divided by the square root of 40. C. The sample variance of P ratios. An analyst is studying annual returns for all listed stocks. She collects data for 100 randomly chosen stocks and calculates their average return. In this context, which statement is most accurate? The 100 stocks represent a sample of the population of all listed stocks. B. The average return of the 100 stocks is a population parameter. C. The population of all listed stocks is a sample. An analyst is tasked with evaluating hedge fund performance. Due to time pressure, she downloads a free dataset of hedge funds that is readily available online, rather than constructing a full population sample. Which sampling method is she most likely using? A. Cluster sampling. B. Judgmental sampling. C. Convenience sampling. A research team is studying mortgage default rates. They divide the country into counties, treat each county as a subgroup, and then randomly select 5 counties. All mortgages within those selected counties are included in the study. This sampling method is best described as a stratified random sampling, B. Cluster sampling, C. Convenience sampling. The limitation of non-probability sampling is the inability to objectively measure representativeness. Selection probabilities are unknown, so sampling error cannot be quantified. A. Probability sampling is not larger or more costly. It is usually cheaper and faster. C. Automatic proportional representation is a feature of stratified random sampling, not non-probability methods. Probability sampling provides measurable accuracy, supports statistical inference, but requires more resources. Non-probability sampling, quick and inexpensive, but lacks representativeness and cannot support valid inference. Probability sampling allows error measurement, non-probability does not. If representativeness and inference are required, use probability sampling. If speed and cost matter more than accuracy, non-probability sampling may be used, but with caution. Proportional allocation is the defining feature of stratified random sampling. The sample proportions, 70, 20, 10, exactly match the population proportions to ensure representativeness. Option A. The error is disproportionate sampling. Equal sample sizes across unequal population segments distorts representation by overweighting small groups and underweighting large groups. Option B. The error is lack of control over composition. Simple random sampling leaves the final composition to chance, which may not reflect the population structure. The contrast is between sampling without structure, simple random, versus sampling with structure that preserves population composition, stratified random. The differentiating factor is whether the sampling process explicitly accounts for and maintains known population proportions across subgroups. The identifying features are 1. Population divided into subgroups, or regions. 2. Random sampling performed within each subgroup. 3. Sample size proportional to each subgroup's population share. This combination defines stratified random sampling. Option A. The distinguishing feature is whether entire clusters are selected and fully sampled. Cluster versus sampling from all subgroups proportionally, stratified. If all regions appear in the sample, it cannot be cluster sampling. Option C. The distinguishing feature is whether the sampling process includes stratification before random selection. Simple random sampling would ignore the regional groupings entirely. Sampling error is the difference between the sample statistic and the population parameter. In this case, it is the difference of 2. 18 versus 20. That's the direct definition of sampling error. B. This describes the standard error of the mean, which measures variability across repeated samples, not the actual observed difference in the sample. C. This is the sample variance, which measures dispersion of data points, not the discrepancy between sample and population means. The 100 stocks are a sample, not the population. The average return calculated as a sample statistic, not a population parameter. This directly answers the question. The analyst is studying the population but only has a subset. B. The average return of the 100 stocks is not a population parameter. Parameters describe the entire population, while this is only a statistic from a sample. C. The population is the complete set of all listed stocks, not a sample. Calling the population a sample is conceptually wrong. The analyst is using convenience sampling because she selects data that is easiest to access, free dataset online. Convenience sampling equals ease of access, not representativeness. It's a non-probability method prone to bias. A. Cluster sampling requires dividing the population into clusters. For example, by region or fund type, and then randomly selecting entire clusters. This is not what the analyst did. B. Judgmental sampling requires deliberate selection based on expertise or professional judgment. The analyst did not apply judgment. She simply used what was readily available. The research team is using cluster sampling because they divided the population into counties, clusters, and then randomly selected entire counties. In cluster sampling, once clusters are chosen, all elements within those clusters are included. That matches the scenario exactly. A. Stratified sampling requires selecting individuals proportionally from each subgroup, not entire groups. Here, they took whole counties, so it's not stratified. C. Convenience sampling is based on ease of access, not structured random selection. The counties were chosen randomly, not just because they were easy to reach. Topic: Central Limit Theorem and Inference. An analyst is studying daily returns of a stock that are heavily skewed. She draws repeated random samples of size 100 and computes the mean of each sample. According to the Central Limit Theorem, the distribution of these sample means will be approximately normal with variance equal to the population variance. Be approximately normal with mean equal to the population mean. C. Skewed, similar to the population distribution, because the population is non-normal. An analyst repeatedly takes random samples of size 40 from a population of stock returns and records, the mean of each sample. The probability distribution formed by these sample means is best described as the sampling distribution of the mean. B. The probability distribution of the population. C. A discrete distribution of equally likely outcomes. An analyst studies the daily returns of an emerging market index that are heavily leptokurtic, fat-tailed. If the analyst draws repeated samples of size 200 and calculates their means, the sampling distribution of the sample means will most likely A. Have the same shape as the underlying fat-tailed distribution. B. Be approximately normal, centered on the population mean. C. Have variance equal to the population variance. The probability distribution of the sample mean, calculated from repeated random samples of the same size taken from a population, is best described as the sampling distribution of the mean. B. The population distribution. C. A discrete distribution with equally likely outcomes. An analyst collects a sample of 100 stock returns with a sample standard deviation of 20%. If the sample size is increased to 400, while the standard deviation remains the same, the standard error of the sample mean will stay the same because the population variability has not changed. B. Decrease by half, since standard error is inversely proportional to the square root of n. C. Decrease to 1/4 of its original value, since sample size quadruples. The following sample of 9 items is selected from a population. The population variance is unknown. 12, 15, 18, 10, 20, 25, 14, 16, 22. The standard error of the sample mean is closest to A. 1.61, B. 1.87, C. 4.00. By the central limit theorem, with a large sample size, n equals 100, the distribution of sample means will be approximately normal, with mean equal to the population mean. The variance of the sample means is reduced to variance divided by n, not the full population variance. A. The variance of the sampling distribution is smaller than the population variance. It equals variance divided by n, so option A is wrong. C. Even if the population is skewed, the CLT ensures the sample mean distribution approaches normality when n is large. The skewness of the population does not carry over to the distribution of sample means. The repeated sample means form the sampling distribution of the mean. This distribution is central to inference and the central limit theorem. It describes how sample means behave across repeated samples, not the raw population data. B. The population distribution refers to the distribution of all individual stock returns, not the distribution of sample means. C. A discrete uniform distribution means all outcomes are equally likely, like dice rolls, which is not the case here. Sample means follow a distribution shaped by the underlying population and sample size. By the central limit theorem, with a large sample size, n equals 200. The distribution of sample means will be approximately normal and centered on the population mean. Even though the population is fat-tailed, leptokurtic, the sample means smooth out the distribution toward normality. A. Sampling distribution does not retain the fat-tailed shape of the population. CLT ensures normality for sample means. C. The variance of the sampling distribution is variance divided by n, not the full population variance. The spread of sample means is smaller than the population spread. The distribution formed by repeated sample means is the sampling distribution of the mean. It specifically describes how the sample mean behaves across repeated random samples, not the raw population data, or a uniform distribution. B. The population distribution refers to the distribution of all individual values in the population, not the distribution of sample means. C. A discrete uniform distribution implies all outcomes are equally likely, like dice rolls, which is not the case here. Sample means follow a distribution shaped by the population and sample size. The standard error of the mean, SE, is calculated as SE equals sample standard deviation divided by square root of n. With n equals 100, SE equals 20% divided by 10 equals 2%. With n equals 400, SE equals 20% divided by 20 equals 1%. When the sample size quadruples, the denominator doubles, so the standard error is cut in half. Option A. Although population variability, standard deviation, remains the same, sampling variability decreases as n increases. SE always shrinks with larger sample sizes. Option C. SE decreases at the rate of 1 divided by square root of n, not 1 divided by n. Quadrupling n reduces SE by half, not by 1/4. Standard error of the sample mean is found by dividing the sample standard deviation by the square root of the sample size. With the sample standard deviation of 4.84 and n equals 9, the standard error is 4.84 divided by 3 equals 1.61, which matches option A. Topic: Bootstrapping and empirical sampling distributions. An analyst computes the average return from a sample of 50 mutual funds to estimate the true mean return of all mutual funds in the market. In this context, the computed average return is a parameter. B. The computed average return as a sample statistic. C. The true mean return of all mutual funds is a sample statistic. When comparing Bootstrap and Jackknife resampling, which statement is most accurate? A Bootstrap resampling uses systematic leave one out subsets, while Jackknife resampling uses random sampling with replacement. B. Bootstrap resampling can produce different results each time it is run, while Jackknife resampling always produces the same results for a given dataset. C. Jackknife resampling typically requires thousands of resamples, while Bootstrap requires only as many resamples as the sample size. The computed average return from the 50 mutual funds is a sample statistic because it is derived from a subset of the population. A parameter describes the entire population, while a statistic describes a sample. The analyst's calculation is based only on the sample. A. A parameter refers to the true mean of all mutual funds in the market, not the sample mean. C. The true mean return of all mutual funds is a population parameter, not a sample statistic. Bootstrap is random sampling with replacement, so results can differ each time it's run. Jackknife is systematic leave one out resampling, so for a dataset of size n, it always produces unresamples and the same results every time. This directly explains why option B is correct. A. The methods are reversed in the statement. Jackknife is the leave one out method, while Bootstrap is random sampling with replacement. C. Bootstrap typically requires thousands of resamples, whereas Jackknife only requires unresamples, equal to the sample size. The statement in C flips this relationship